A really good first step in solving any problem involving time value of money is to construct a timeline. In fact, timelines can be really useful for any problem, but especially time value of money problems. So here are a couple of basics. When we're setting up our timeline, time zero, that's the reference point. It's always it's the earliest point in our analysis. It's often today, but it's not always necessarily today. Sometimes we begin our analysis at some point in the future, or sometimes we might be evaluating things that have happened in the past, and so the time zero, the beginning of our analysis, would actually be some point in the past. Time one is right here. That's one period after the reference point. You can see here's the reference point. One period later is here. That's time one, time two, time three. Time t is just a general expression for t periods after the reference point. So time 1, time 0, time t represent a particular point in time. Period 1, period 1, that the term period reflects an entire period of time. And you can see here's period of time, it's the time from 0 to 1. So like year 1, the first year might be from today until 1 year from now. Period t ends at time t, so it starts at time t minus 1. So let's say that's the 8th year. It would be from 7 years from now to 8 years from now is year 8. C within the little subscript tells us at what point in time a cash flow takes place. So you can see we have here, we have C0, that is the cash flow at time 0. C1 is the cash flow or expected cash flow at time 1. C2, cash flow or expected cash flow at time 2. And although, again, the general is CT, C sub t, which is the expected cash flow or cash flow at time t. And you can see finally dot dot dot, that represents the passage of time. So for example, suppose we were looking at 50 years, we wouldn't necessarily need to put all 50 years into our timeline. You can see here we've got 0, 1, 2, 3, 4, 5, then dot dot dot, 49 and 50. So those are some of the basics. Here's 4 steps to think about when putting together a timeline. The first is the cash flows, both known cash flows and unknown cash flows. The direction, which we'll talk about in a second, magnitude and timing, when they happen, how big they are, and whether they're going out or coming in. Step 2, the length of each period. So we have a timeline with notches. Is each notch represent a month or a quarter or a year? And for each particular situation, there's a appropriate length that you need to use. Then once you have the length of each period, you've got to get the relevant rate of return for that period. So again, if we're looking at a timeline where everything's denoted in months, we need a monthly rate of return. In step 4, that's the big one. What do we know? What don't we know? And what are we trying to achieve here? So step 1, direction, magnitude, and timing. Direction, if we know the cash flow, and if it is an inflow, it is money coming to us, that will be positive. Also, if we're looking at an asset or a security and it has positive value, a building, a stock, a bond, a piece of real estate, then the value of that is reflected as a cash inflow and it's positive. That's a little bit different than with the financial calculator where we have the sign convention where sometimes if it is at the beginning of a period, even if we own it, then we reflect it as a negative. We assume, okay, we put the money in, that's how we got it, and then we want to look and see what the future value is, that's how much we would get back. When we're dealing with a timeline, we don't need to worry about the sign convention. The timeline shows things a bit more directly. So if we're looking at the value of something and we own it, it's positive in the timeline. Cash outflows, money that we spent, or money that's paid out, those are negative amounts. Often money at the beginning of a project, or if there's a time, where we have to pay a bill, those are cash outflows. Magnitude, just how big, $100, $1,000, $1,000,000. And finally, timing. When does the cash flow take place? We know time value of money. If we have to pay $100, it is a big difference whether we pay it today or whether we pay it in 20 years from now. Step 2, identify the length of each period. And so again, we have a timeline. And so suppose this is 1 year from now, or this is today and this is 1 year from now. Here you can see there's two notches. The time period is a year. The time period between the first notch and the second notch is a year. But it's possible to also reflect a year as 2 half years, or 4 quarters, or 12 months. So again, in all the cases I've shown, we're looking at a time period of 1 year, and then it just depends on the particular circumstances, and that'll become more clear as we work through problems, making sure to reflect it as whether each notch needs to be reflected as a quarter or a semi-annual period. So that's really important. Here's a couple of tips so that you can figure out what the appropriate period length should be. First, if a rate's given and it's for a period that's smaller than a year, so you're given a monthly year, or you're asked to solve for the quarterly rate, or you're given a semi-annual rate, then the timeline period equals the period for that rate. So if you're given a quarterly rate, then your timeline would be a quarter. And if you wanted to deal with something that happened a year from now, that would actually be 4 periods from now, 4 quarters from now. Second, if there's compounding, which is a topic we'll talk about later, then the compounding period, how often is interest compounded, how often are returns compounded, then if it's compounded quarterly or monthly or semi-annually, that is what a period will correspond to. 3, if the cash flows reflect an annuity due, or a perpetuity, then the period in the timeline is going to be consistent with how frequently those cash flows are paid. So annuity due, and perpetuity are cash flow, series of cash flows that involve regular fixed cash flows, or in the case of a perpetuity, regular cash flows that grow at a constant rate. And how often those regular cash flows take place, if they're monthly or quarterly or semi-annually or annually, then that is what the timeline will reflect. And finally, if everything is annual and nothing is less than a year, then the timeline period's a year. So these are 4 things to key on in this class. So I actually think that identifying the appropriate length of a period is fairly straightforward, as these things will whenever they are less than a year, they'll always be consistent with each other. So step 3, find the relevant rate. So you may be given, not now, but later in the course, you may be given an annual rate, but you realize you need to get a quarterly rate. You need to convert that annual rate to a quarterly rate. For now, you'll be given the relevant rate, but later when we have some more tools, you may be given the annual rate and you have to get the monthly rate or the quarterly rate or the semi-annually rate. As you'll see, that's a pretty straightforward conversion to make. And step 4, this is where we're going to be spending much of the course, is basically solving the problem. You set up a timeline, you know what you know what you don't know, you know what you want to know, and you have some tools, you have some understandings, and let's see how we can take advantage of things that we know how to do to answer the question we're trying to answer. So here's an example that shows how important it is to pay attention to these things. So you're going to invest $900 today, and you want to know how much you'll have in 1 year. And we're actually going to look at 3 different cases. Here, the interest rate is 12% per year. So everything's annual in this case. So our timeline is, today, 1 year, and we can stop there because we just want to know how much we'll have in 1 year. So 900 times 1.12 to the first, we'd have $1,008. What if we have a situation, again, we're going to invest $900 today, we want to know how much we'll have in a year, but instead of earning 12% per year, we earn 6% per half year. Well, look, we have a rate for a half year, so our year is now actually 2 half years away. Our periods are a half year, 6 months. So here we are today, 6 months, 12 months. We can stop because that's when we want to know how much money we'll have. And it's 900 times 1.06 times 1.06, 1,011.24. A different amount. Both cases we're putting in 900. We want to know how much we'll have in a year. And as we'll see, this is actually equivalent. 6% per half year is actually equivalent to 12% per year. And again, here we have another case, which is $900 today. How much will we have in a year? At 1% per month, which again, as we'll see, can also be stated as 12% per year with some additional things. But here, we're basically putting in $900, and then a month later we'll have 1.01 times that times 1.01, 1.01, and we'll do that 12 months. We have a rate for a month, and that's why the periods are a month. So how much would we have? 900 times 1.01 to the 12th, $1,014.14. So you can see, in all cases, we want to know how much we would have in a year. But in the first case, it was in one period. In the second case, it was in 2 periods. In the third case, it was in 12 periods. And therefore, it was very important to pay attention to the length of our period, and we had different timelines in all 3 situations.